Okay, so let's begin. We're going to look at this first question. It says, two friends, Taylor and Ethan, had just bought their first cars. The equation y equals 20.3x represents the number of miles y that Taylor can drive her car for every x gallons of gas. Okay, that's one thing. Ethan uses 4 gallons of gas to drive 127.6 miles in his car. Use the information to complete the sentence. And the sentence we have to complete is Ethan can drive blank miles. I'm assuming that's a number. Blank miles, blank than. So than tells me that we're going to compare more than, less than Taylor on 1 gallon of gas. Okay, so on 1 gallon of gas. So they're asking for mileage. How far can you go on 1 gallon of gas? And that's pretty much a big deal, right? Because especially with gas being so expensive, the farther you can go on 1 gallon of gas, you got better mileage, and it's not as expensive. Um, so let's take a look. So let's go back. You may want to grab a marker, a dry erase marker, or a highlighter, or something to do some underlining or highlighting. Okay. So they bought their first cars. The equation, let's highlight the equation. Y equals 20.3x represents the number of miles y. So y is the number of miles that Taylor can drive for every x gallons of gas. So that equation represents Taylor. Okay. Now let's move on to Ethan. Ethan uses 4 gallons of gas. So for Ethan, it's 4 gallons of gas to drive 27.6 miles. Okay. So let's see what we have. Well, let's start off with Taylor since they mentioned her first. Let's do some calculating for Taylor. And what we want to find out about Taylor's is the mileage. How many miles does she go on 1 gallon of gas? And they're giving us an equation, right? Let's just go back and see what do the variables represent. So what does y represent? Yeah, miles. And x is the gallons. Okay, so what do you think, does the number 20.3 represent? Does it represent miles? Does it represent gallons? Does it represent gallons per mile or miles per gallon? Gallons per mile. Well, one way to check is just pop in a number, right? So remember, our output should be miles, right? Because that's what y is. So if I have 20.3 gallons per mile, and I multiply by, what does x represent? Gallons. If I multiply by, let's say 1 gallon, which is one value of what, would the miles and the gallons cancel in that case? Would miles cancel with gallons? Remember unit rates? No, they wouldn't, because they have to be identical. Gallons won't cancel with miles. Gallons cancel with gallons, and miles cancel with miles. So doing that wouldn't work. So let's flip them. Okay? So let's do 20.3 miles per gallon and multiply that by 1 gallon, which is, remember, X is gallons. Do you see that gallons would cancel in that case? And what units am I left with after that? What units are left? Miles, right? And that's the answer I want. I want the answer to be in miles. So basically, the number 20.3 represents the mileage. It's the miles per every 1 gallon of gas. So they're giving you that number for free. Okay? So they're telling us Taylor drives 20.3 miles for every 1 gallon. Okay? When they give you the equation, that's the best situation, because whatever rate they're giving you, remember this number is always going to be a rate, the number being multiplied with a variable there. That's one way to check what does a variable represent. Kind of play around with the units. And in this case, it's exactly what we want, miles per gallon. Okay, let's talk about Ethan here. So 20 miles per gallon is not that great, by the way. I don't know what kind of car Taylor bought, but the mileage is not so great. Okay, let's figure out the mileage for your car there, Ethan. How many miles is it going? 127.6 miles. And we're going to divide that by 4 gallons. The thing is, we don't want for every 4 gallons. We want for every 1 gallon. So we want to turn this into a unit rate. So this is where we have to do a little division. Either on your Chromebook, on a calculator, on your phone. But we got to do this division. 127.6 divided by 4. And we get 31.9. That's much better. So there's the information we needed for Taylor. It was pretty much given to us in the equation, 20.3 miles per gallon. For Ethan, we had to do a little work, but 31.9. Okay, so what's the difference in mileage? What is that?
One of them has 11.6.
11.6. Ethan can travel 11.6 miles more than Taylor on 1 gallon of gas. Maybe it's one of those hybrids. Actually, hybrids have way better mileage than that. But not too bad. All right. Any questions? Okay. Well, that's the first one. Whenever they give you an equation, kind of focus in on the unit or the slope number, the rate of change. And based on whatever they're giving you for the units, in this case, miles and gallons, you can figure out what the unit represents. Whatever unit represents Y is your numerator. In this case, it was miles. Whatever unit represents X is your denominator, in this case, gallons. And that's how you figure out what does that rate represent. Okay? Any questions? Okay, let's move on. Number 2. So number 2, we have 3 friends. Blake, Kevin, and Owen are saving different amounts of money each week. Blake started with $14 and added $12.50 each week. Kevin's savings are represented on the table below. So that's for Kevin. And Owen's savings are represented on the graph. Okay, so there's the graph for Owen. And what do they ask us to do? Sort the three friends in order from least to greatest dollar amount saved per week. Okay, so this is what we need to find out. We're going to sort who saved the least to who saved the most. So let's figure out how much they saved per week. That's what we have to figure out, savings per week. So let's take a look. Let's start with who's our first person? Blake. Blake started with $14 and added $12.50 per week. Does that give us his rate of savings? Do we know how much he's saving a week? $12.50, right there. It's there for the taking. So for Blake, it's $12.50. Okay. May want to write that down. I'll write it down here actually, maybe. Blake. $12.50 per week. Okay. Moving on to Kevin. For Kevin, we have a table. We're assuming it's a linear function. So all we need to do is take any pair of numbers and find the difference. So like here. Looks like we went from 4 to 8, right? So that's a gain of 4. And then we went from 66 to 96. So that's a gain of $30. So it's $30 every 4 weeks. But we want it for every 1 week. So over here on the side, why don't we do that? $30 divided by 4 weeks. And what's that going to give us? Again, calculator time. 30 divided by 4. You get $7.50 a week. Oh, let's just write it down here. So this is Kevin. $7.50. $7.50 per week. Okay. So 2 down, 1 more to go. We've got Owen. For Owen, they give us the graph. But it's basically, we're going to do the same thing we did here, right? We're going to subtract and divide. So let's see. We want the dollars in the numerator. Think of it as finding the slope. So he went from what dollar amount? He went from $71 to $111. So it's 111. Take away 71. And then he went from $3 to $5. So 5 take away 3. Or not, he went from week 3 to week 5. So 5 take away 3. Those are the weeks. So let's see what that gives us. What do we get there? What's 111 take away 71? 40? Check my math on that. Is that going to be 40? 111 take away 71? Five take away 3 is 2. So we got $40 every 2 weeks. So what does that turn out to be every week? So for Owen, it's $20 per week. So who saved the least? He goes first. Then Blake. And then Owen saved the most. Okay. So again, you're just looking at the rates basically. Sometimes they'll give you the rate, like they did here in the sentence. Sometimes they'll give you a table, and you got to find the rate of change the way we've done before. And sometimes they'll give you a graph. And we basically use the slope formula here. Remember the slope formula? You subtract the y values and divide that by the difference in the x values, and then just simplify. Okay? All right. How are we doing? Any questions? You're gonna have questions just like this on the delta. Okay, let's go ahead and look at number 3 now. For 3 and 4, it's gonna be different. We're actually gonna construct equations, which is more of what we're gonna be doing tomorrow. But this is good practice for that. Okay? So let's begin. So Jordan is deciding between 2 parking garages. Garage A charges an initial fee of $9 to park plus $4 per hour. That looks important, so I'm going to highlight that. Then we have garage B charges an initial fee of $3 to park plus $6 per hour. So I'm going to highlight that because it looks equally important. Okay, so now it says let A represent the amount garage A would charge if Jordan parks for T hours. Let B represent the amount garage B would charge if Jordan parks for T hours. So this is telling me we're going to call A and B what the costs are for parking in each garage and the equations we're going to make. And we're going to use the variable T for the amount of hours. Okay. And this is what we're asked to find. We got to do 2 things. Write an equation for each situation in terms of T. That's the first thing. And the second thing is determine the hours park T that would make the cost of each garage the same. It's called the break-even point in economics and stuff, where one thing equals the other, or one value equals the other. Okay? And that's what we want to figure out. When you would pay the same in either one of the garages. Okay, so I know it seems like a lot to take in, but let's just take it step by step. Let's start with garage A. Let's figure out the cost for garage A. And they're telling us to use A, the variable A for the cost of the garage. So instead of Y, we're going to use the variable A. A equals, and then read that part in green that we did.
Charges an initial fee of $9 to park plus
$9 plus, they're even telling you do plus. How do we handle $4 per hour using the variable T for the time? 4T. There's our equation. A, the cost for parking there, is 9 plus 14. Okay? It's going to be kind of the same for garage B, using the information they give us there. Okay. For B, it says the initial fee is $3, so it's going to be B this time, is the cost, equals $3. So at the beginning, it looks like B is cheaper, right? Because they only charge you the initial fee of $3. Okay, so that's the first part. Write an equation for each situation. We've done that. Now what we want to do is determine the hours parked that would make the cost of each garage the same, the break-even point, where one equals the other. So we did this when we were solving systems. We basically have a system, two linear equations, and what we want to do is set one equal to the other. So I want to replace maybe 3 plus 6t for A in the equation and then solve it. Watch. We did this before. So instead of A in this equation, I'm going to put 3 plus 6t. And then on the other side, I'm going to put the other equation, or the right side of this equation, 9 plus 4t. See what I'm saying? This equals that. I want to know when they're equal. Well, it's an equation, so I just have to figure out what number t represents in this equation. And we've done that. Not intimidated. In fact, do you notice we have variables on both sides? T on the right, t on the left. What if I want to get rid of this 4t on the right? I'm used to the variables on the left. Take it away. By now, we're experts at this. Boom. And we've got 3 plus 2t now. Equals 9. And let's get rid of the 3. And that gives us 2t equals 6. 9 minus 3 is 6. So let's divide out the 2. Yeah. And we get t equals 6 divided by 2, which is 3 hours. At the 3-hour mark, if you pay for, at 3 hours, they would cost the same. After that, garage B is going to be more expensive, and garage A would be cheaper. Okay, but the break-even point, the point where they're equal in price, is 3 hours. Okay, any questions? All right, the last one is going to be very similar to this. We're going to set up some equations. We're going to write them down, and then they're going to ask us where one thing equals the other. One value equals the other. Okay? Let's take a look. Here it is. Caleb planted 2 trees in his backyard. Okay. At the time of planting, tree A was 37 inches tall and tree B was 16 inches tall. Each year thereafter, tree A grew by 4 inches per week and tree B grew by 7 inches per week. Okay, those are some rates. Got to keep that in mind. Let A represent the height of tree A, T years after being planted. So they're telling us use T as a variable for time again. And let B represent the height of tree B, T years after being planted. Okay, so 2 equations. And this is what they're asking us to find. Write an equation for each situation. So this is what we have to answer. I'm going to highlight that. And then the other thing they're asking us to find is determine the height of both trees at the time when they have equal height. Okay. So this is a little bit different. Determine the height. So we're going to do a little more than what we did here. Watch. We want to know when both trees would be of equal height, but we want to know what height would that be. Okay. So let's do it. Let's start with tree A. It's similar to what we did there. So let's go back and pick the numbers we want. So it says tree A was 37 inches at the start. And what was the rate of growth? How fast was it growing? Yeah. So that gives us our equation for A. A equals, right, 37 plus 4t. And then let's do tree B. And for tree B, they tell us it was shorter. It was 16 inches. And then the rate of growth was faster, though, 7 inches per year. So that's the information we need for B. So B, the height of tree B is 16 plus 7t. Okay. Any questions on that? Okay. So we're just going to keep that. That's part of our answer. We did the first part. We wrote the equations in terms of t for the heights. The other thing is we want to figure out when they would be equally tall and what height would they be at. Okay? So we got to do the same thing we did before. Set one equal to the other. Okay? So maybe this time I'll do 37 plus 4t equals 16 plus 7t. Okay?
So we get rid of 7.
Yeah. And this is going to give us a negative for a while, but that's okay. We're not intimidated by that. Negatives ain't no thing. 37, 4 minus 7 is negative 3t equals 16. Okay. And now let's get rid of the 37. It's a two-step equation, so we'll subtract 37.
Does it matter if we first take away the 4t or 7t?
Not really, other than if you take away the 4t, you would have variable on the right at the end. So if that doesn't bother you, then either way, you get the same answer. So negative 3t comes down equals negative 21. And we'll divide by negative 3.
T equals 7.
Yep. Thank you, sir. 7 years. Okay, so that's important. We need to know that number. Because after 7 years, both trees will be the same height. Okay? Now, we want to know what that height is. How can we figure that out? we need to know the height of the tree after 7 years. Do we have an equation or something that would tell us that? Yeah. Yeah. Pick your equation, either the first or the second. Doesn't matter which one. And so let's do it. Let's take this one. So I'm going to do A equals 37 plus 4 times 7. So this is very much like what we did when we were solving systems. All right. So A equals 37 plus, what's 4 times 7? Okay. And now that's 65. And what were the units for inches? Thank you. 65 inches. So this is the part we needed to answer. After 7 years, both trees will be 65 inches tall. Okay? Any questions? All right. Well, this is going to be what the delta is on. I think you got 5 and 5. 5 questions like the first 2 problems we did, 5 questions like these. Okay? So let's go ahead and get